This video is not a mock interview. This video is a mentorship session. What does that mean? A mock interview is evaluative. They draw a line in the sand and they tell you what side of the line you're on. Are you hired or are you no hired? It informs decision making and it sets expectations. This is a mentorship session, not a mock interview. In a mentorship session, there is no line. There is only coaching and appreciation. So you're getting increased knowledge and skill, and you're being encouraged to go further. Now, great learners know it takes evaluation and mentorship. Both are valuable inputs to learn as much as you can. So, we made this video for you to get exposed to mentorship. Maybe you want to do some mentorship sessions of your own. To observe the candidate in this situation, to be thinking ahead what you would do if you were in their shoes, and to do an experiment. We're going to make a ton of system design content for mid-level to senior engineers, and we want to see what the community thinks so we can make a lot more of that. In this video, you will see a senior engineer who's done a ton of great work at Amazon, but she doesn't have that much experience with system design interviews. She's going to do a mentorship session, not a mock, with a system design expert. So, we hope you like it. We hope you tell us what you think. We encourage harsh feedback, maybe delivered personally to my email. We want to know what you think, and you can join our Discord community, which is in the description below. Come to our next event, and thanks for stopping by. See you next time. Let's kick it off. So, what the agenda for the day is some very brief intros for me and our two very talented stars for the show today. Then we will be doing some live coaching for 25 to 30 minutes. After that, we're gonna have a big portion of the session devoted to Q&A. For everyone who's been saying things in the chat about stuff that's confusing, the Q&A portion is for you. And then we're gonna do a brief outro and then get you out of here. We're not doing a Discord Q&A today, but we'll have more Discord events coming up. Intros, real quick. Hi, I'm Kevin. I'm the developer advocate at interviewing.io. We're releasing a system design guide in the next couple of weeks. It's going to be the go-to system design guide for mid and senior engineers. So I'm very excited about that. And these were two core contributors to that project. So that's a little bit about me. Dima, what about you?
Hi, everybody. I'm Dima. I'm glad to continue this quest with interviewing.io to create great content. I'm an engineer. I reached senior levels at FAANG a bit over 10 years ago. Since then, I was head of engineering, head of machine learning, startup co-founder, CTO. For the past couple of years, enterprise architect. I design and build large systems myself. I interview people who design and build large systems. And my hobby was and remains to help people get better at this. So let's do it.
Awesome. Grace?
Hi, everyone. My name is Grace. I'm a combat vet turned software engineer, so definitely non-traditional background, like I think a lot of folks are coming through interview.io materials. Happy to be the guinea pig today and have a chat with Dima and learn from him and see if I can understand, like, you know, the rest of you, like how to better interview in terms of system design questions.
And keeping in line with this is a brand new thing that we're doing. We have no idea how this is going to go. Not only is Grace the guinea pig, we are all the collective guinea pig. Anybody that showed up. This is a new thing. So we need your help to know how it goes. And when we give you a feedback form afterwards, the feedback form might call this a negotiation workshop. Don't mind that. This was a system design workshop. You know that because you're here. So we would really appreciate feedback on the workshop when we're done because it is a new thing. Secondly, if you're here to participate. So remember that. Now, this third point is important, but we're going to talk about it in our next slide a little bit more. The value of this workshop is exponentially increasing your system design skills in less than an hour. The reason that it's possible is because of the workshop design, which is about you being a third-party observer, which we'll get to in a second. The last formal thing is there's a difference between the QA and the chat. If you want your question answered 100%, put it in the Q&A function. At the end of the workshop, we'll go and we'll sort those Q&A questions from most upvoted to least upvoted. And then at the end, we'll answer them in that order from the most upvotes to the least upvotes. But if you put something in the chat, I'm going to be scanning the chat And if it's worth interrupting what Dina and Grace are doing, we'll say it. But otherwise, most stuff in the chat won't get answered. So that's the difference between those two. The last thing, there are 3 bundles of skills according to the Harvard Negotiation Advanced workshop I just went to last week. There is the first position. So this is in any human interaction. The first position requires self-awareness, ability to talk to yourself, to manage your own emotions, to set priorities, and to assert your own perspective clearly and persuasively. Grace is in that position today. Dima's in that position today. None of you in the audience are in that position today. The second position is the ability to step into someone else's shoes and find a place of genuine curiosity about others' perspective, emotions, interests, and priorities. None of us should be in that position today. The third position is where everyone in the audience will be, and that is your ability to observe and diagnose what's happening, to adjust strategy if you were Grace, and what thoughtful choices about what Grace might do next or what Dima might do next. So that's the value of this workshop. You will get so much more from watching your peers or from watching yourself if you record yourself than you'll ever get from being in the first or the second position. So 3 cheers for us, 3 cheers for our talent, and Grace and Dima, let's kick it off whenever you're ready.
Shall we?
Yeah, I'll go ahead and share my screen, which will have just a little bit of a space for us to map some stuff out as we discuss. Can you see my screen here? Sure.
Yep.
Okay. All right, Dima. Throw
Let's
it
do
out.
it. Let's do it. Let's dive straight in.
Okay. I'm gonna make some notes while you talk as well, just so I.
So to set the tables, I like to interview people under the assumption they are like half a step above the level advertised, so that I think it's the best learning experience. It's absolutely the best experience when mentoring and when recording videos like this. So I'm going to assume you are level 5 senior, maybe slightly above, and see what happens.
Okay.
Which means I'll deliberately assume I don't need to phrase myself explicitly with respect to all the questions I ask. It's kind of on you to clarify the flow, to ask the questions, to navigate it. I'll help as needed, but don't be shy to just control the narrative. All right. Here's the problem. It has many different names and shapes and forms. So let's just dive straight in. You have a large file on your computer. The way I like to ask this question is: you just flew CNA to SF, and you've been working hard on your MacBook. You were certainly offline, right, while flying, and now you need to run some MapReduce. You work for Google, so before you get onto your current drive, you'd like to copy this file to a Google data center over this imperfect, slow-ish Wi-Fi or tethering or whatnot at the airport. The data center is many machines. The reference number could be 10K machines, 10,000 machines.
Okay.
To throw in some numbers, it takes, let's say, about 5 seconds to copy a file from one machine to another machine in the data center. And it takes about 30 seconds to copy this file from your laptop to any machine there. So far, so good.
Mm-hmm.
Your end goal, your ultimate objective, is to make sure every single machine in this data center contains this file.
Oh, okay. Okay. And you said, I might have missed what you said about MapReduce.
Not important. It's just you plan to run some job that requires this file to be on every single machine.
Okay. Okay. All right. So I just want to make sure that I'm understanding. So you want every machine to contain the file. It doesn't necessarily need to contain, like, be copied, sequentially, or there's no constraints on like the order of which machine gets the copy first, right?
Correct.
How long and the largeness of the file is just communicated there through the copying duration. Okay. So
How do you start?
how would I start? Okay. Well, is this something that's going to happen? I'm assuming that we're talking about something that would happen in a common situation where you would want to replicate this multiple times, right? So I'm thinking about first, like, we have I'm just going to get some components out here so that I can think through this. Let's see here. Do I have some little icons here? Oh, yeah, let's do it. Okay. All right. So here's my local. I'll just pull this out here. If I can. There we go. And then we've got. This might take me seconds. So we're not worried about. I just want to first. Before we get into any sort of high level design, so close this for a second. So we're not worried about like the load balancer like hitting a certain data center. We know that it's already going to go to be geolocated to the closest data center. Is that correct?
Let's keep it simple. Let's say you can access any single machine, both externally and internally. That's a bit insecure, but I want to focus on the protocol part.
Okay. So I guess like I would the copy from the machine to the machine. I guess I'm thinking that there should be some sort of shared persistent data storage where I would want this file to be uploaded. So I guess I would like a little bit more of a clarification on like the data center machines are all in the same region, and I guess I'm wondering if I fully understand this problem.
So this persistence part, yeah, that's the key. But if we have something like a Google file system, we would just use that.
Okay.
So effectively, the problem is about designing that part, more or less. Just assume every single machine has a hard drive that has more than enough space to contain this file.
Okay.
And the rest is pretty much all on you. I really like to ask this question, or pretty much any question, in the following format. Imagine it's 1999. Imagine nothing exists. So even if you could use something that you know exists, I would eventually ask you to explain how it works. So we might as well start from the first principles.
Right. Okay. So I guess there would be some, if you get down to the basics in that case, like, there's going to be the HTTP request that in my mind is going to go through a load balancer and hit the servers and then hit the shared storage after that point.
So you're going to use a web server on the machine you're going to go to, and then like upload file there, like Apache or Nginx via HTTP.
Say that one more time.
So if you upload by HTTP, it sounds like you have some web server that would likely be Nginx or Apache that just supports file upload.
Right, and it would fetch from or correct. So I guess
so if you do that, look, that's a good idea. If you do that, in 30 seconds, one machine in the data center will contain this file.
Yeah, I mean, I guess like I would think that, and it's not like I want from my computer to save a file and then save to it's not going to be like multiple requests from me. It should be one request from me to the data center. And then I'm imagining that like what I would want is to have some sort of persistent storage that's updated. And then the rest of the, wherever I'm storing this file would read from that, common place rather than it coming from my local every time. Because I want to do 30 seconds from my local to one machine, and then I want the rest of the machines to kind of sync up. I guess there is some ambiguity here for me in terms of what, and because this is more of a mentorship, I'm going to just, dig into this with you. But are you hoping for me to talk about database replication, or like having some kind of state data that's in persistent storage, or like, I don't want to think too big about this, but I also, so if there's a file, yes, there's going to be an HTTP request through a web server, and I would want that to be the only thing that's coming from me, from my local.
Look, what we will design at the end is the common denominator for multiple techniques of replication. DB replication would use the same technique. When you say persistent location, persistent store, it would probably be part of these 10K machines. So you could say, hey, you know what? I'm going to dedicate this one machine or these 10 machines as this persistent store. But it's going to be subject to the same constraint, that it can only, if this machine sends files to other machines, it's 10 seconds.
Right.
Which means if it sends a file to 10 machines, it's 100 seconds, because the bandwidth is a constant for this machine. So even if you design a perfect persistence store on, let's say, 10 machines, you would only win 10x compared to copying from one machine.
True. Okay.
Let's maybe start from your first.
I'm thinking there's got to be a way that's better than that. Okay, let's think. So we're suggesting that there's a way. We're assuming here that there's a way to copy the file from machine to machine that's faster than 10 seconds each. I might not be familiar with this, but let me think through it here.
Well, you can't cheat physics. You can't cheat bandwidth.
Right.
Let's start with the first idea. Let's say you start from uploading the file from your machine via HTTP to one of the machines in the data center. I'm not saying it's a good idea. I'm not saying it's a bad idea. But let's say you start from that. This certainly works. 30 seconds of wall time have passed, and one machine of 10K in this data center contains the file. What would you do next? Or rather, what would that machine in the data center do next?
I think I would have some sort of pub sub sort of message. That's what I'm kind of used to, is like, if there's something ready to an action or task that's ready, I would do some sort of message queue where there would be some kind of notification that a file is ready to be copied or to be refreshed or replaced, or whatever the constraints may be.
So if it's a pub sub, it's a good idea. Usually the way it works is you publish small messages. You're not going to put a multi-gigabyte file as a single message.
Right, you're going to have to say file's ready, basically, or here's.
I missed that?
No, go ahead. Continue.
When people use pub subs, the main idea is to decouple the publisher and the subscriber, the writer and the readers. If it's a pub sub where one machine writes some part of the file and every other machine reads this part of the file, if it's 1 to 10K, that's a huge fan-out factor. Not many pub subs can handle this magically. So our problem effectively becomes designing this pub sub.
Okay.
Let's approach it maybe from a smaller scale. What if you don't have 10K machines? What if you have 5 machines?
Okay. So we're really not worried about the sequence of when we can't speed. I guess I'm mostly curious about like, okay, our concern right now is the speed of the copy, but we can't, I mean, can we do this synchronously? Can, four machines, sync from the one machine synchronously? Or
You can,
is there
but
really
look,
no way?
if you do that, so it's part of the problem statement that it takes, you wrote it as 10 seconds. It takes 10 seconds to copy the file from one machine in the data center to another one. If it's a fan out from 1 to 4, then clearly the throughput, the bandwidth, the speed at which the file is copied is divided by 4, because you can only send one file every 10 seconds, like volume wise. So that's a good idea. You can spend 30 seconds first to copy the file from your machine to this one machine in the data center, and then 40 more seconds for 70 total, 1 minute, 10 seconds to copy it to all 5 machines. The question is, can you do better?
Okay, can we do better
like
than
that? That, by the way, is the first complete solution we have. Copy from my laptop to one machine in a data center, and then stream it from that machine to every other machine. For a small number of machines, this is not too bad of an idea, right?
Okay, but we want to do faster than that. Yeah, because we only have, like you said, when we have 10K machines, it'll be different. Okay. Okay, let's think of other ways to speed it up. I mean, we can always, I guess I'm wondering what other little more, I guess, detailed things inside of that. And we're not worried about traffic. We're not really worried about traffic load. We're just, okay. Just thinking.
Not only we're not worried, we want to utilize all of it to speed up the process. Our end goal is to minimize the time from start to end, right? So ultimately, by the end of the day, this file is on all the machines. If you like, it's a little hint, but it's appropriate, I think. What you want to do is to maximize your utilization of the network. If you only copy from one machine to all others, then every other machine is kind of slow. It's kind of slow.
Right.
It's not using most of its traffic.
Okay, thanks for the hint. So basically you're saying instead of there being like one machine that then is copying to Kinte, we're gonna, every time there's a new machine that has the copy, we can add that to the pool of machines that are able to be copied from, and that could speed it up.
Exactly.
Okay.
So if you do it this way, in terms of let's forget it's an SD interview. Let's pretend it's algorithmic for now.
Okay.
What's the complexity of this process?
Well, it would be slightly better than linear if we did it this way. I mean, it would instead of it being, I guess a fourth or whatever, it would just be yeah, I mean, that in terms of the algorithm, we're saying like, okay, from, as long as, so let's say there's a pub sub or something, as long as, or whenever this file is uploaded and exists on one machine, start copying from the pool of available machines, and as the pool increases, it's it would be linear initially, but yeah.
You're trying to make it, I think, a bit harder for yourself by using different words. Your pool of machines is growing, right?
Right.
Eventually, it contains 10K machines. So what's the nature of this growth? You copy to one machine, then what happens then? What happens later?
You copy to one machine from the local. You copy to a second machine from the data center. Then it gets faster as it processes. every time a new machine is added, the speed of the whole copying is increases, but I'm not sure if there's a specific word you're looking for.
So you copy to one, then this one copies to one more. Now the pool is 2 machines.
Mm-hmm.
What happens in the next 10 seconds step?
Then we would copy from 2 machines, so it would go twice as fast, and then
So
it
it
would
copies
go 4 times as
twice,
fast.
yeah, twice as fast as the key. So it goes 1, 1, 2, 4,
Mm-hmm.
8, 16, 32. Sounds like powers of 2.
Okay.
Right. So that's exponential.
That's
And if it grows exponentially, then how long does it take to get to certain constant threshold? In this case, 10K.
Okay, math. I generally avoid math. Yeah. So you want to know how many seconds this would take?
Oh, it's more like how many doublings needs to happen until you hit 10K. How many times do you need to double your pool until it's 10K? I don't need a number. I need your instinct.
I have a number. Oh gosh.
What's the complement of an exponential function? What happens if you mirror it along the y equals x axis arrow?
If you mirror it,
like you flip x and y.
Mm-hmm.
What does an exponent translate to? So your first function, the exponent, goes like 1 becomes 2, 2 becomes 4, 3 becomes 8.
Yeah, and it goes.
So your other function would be 2 becomes 1,
it
4
would
becomes 2,
out fast.
8 becomes 3.
Mm-hmm. Yeah.
So the exponential grows, and this one goes like it slows down, right?
Yeah, it would go like, I can't do it the whole thing.
Yeah, that's pretty hard to draw.
Yeah, it's like, oh no, arrows don't do that. Where's an actual? Yeah, but basically what we're saying is, first it would be 1-to-1, right? And then it would speed up so quickly because the number of
right. That's exponential.
Yeah.
And now like mentally rotate this along the diagonal axis.
Okay.
Replace x and y.
Okay. So instead of it so yeah, okay. This way, basically, something like sort of like
about that, yeah.
Yeah, it would be
well,
like
that's people are suggesting in chat. Yeah, that's the log. That's the logarithm. So
okay.
That's to get from 1 to 10K.
Mm-hmm.
That's from 1 to 1K. Binary log of 1K is about 10, and then I guess 3 more 13 steps would be 8K. So
Mm-hmm.
14 steps would get you to 16K. So it's 14 steps, which in this case would be 140 seconds plus 3170. I believe I saw this answer in the chat. So
Thanks,
if you do it this way, the final answer is 30 seconds plus 10 seconds times binary log of 10K.
Okay.
Now the question is, can we do better?
Can we do better? Okay.
The trick is to realize that at the very beginning of your process,
mm-hmm.
most of your connections between most of the pairs of machines are unused.
So at the beginning of the process, most of the pairs of connections are not being used.
So in the last step, when approximately half of the machines, well, slightly more, 8K, have your file, you would pretty much utilize all the network connections. But then at the first 1, 2, 3, 4 steps, like let's say take first 4 steps, you're going to get to 16 machines of 10K. Mm-hmm. So 9,984 machines are doing nothing. They are clueless. They are just waiting their turn.
Mm-hmm.
And you'd like to make use of them somehow.
I mean, okay, so we said that, so we've already thought about, pub sub fanning out. We've thought about fanning out in a way that like draws from the pool, in an exponential way. And we want to speed it up even more, you're suggesting, by increasing the network.
Well, it's safe to say you cannot speed up this exponential under the constraints that there's only so much you can do.
Mhm.
If you copy the file as a whole, there's only
Right,
so
and
much
we
you
could
can
break up
do.
the file. That would be fun. We could break up the file so that, we could even save it line by line, really, if we wanted to.
If it's a text file.
Right, if it's a text file, true. It definitely depends on what kind of file we're talking about. What kind of file are we talking about?
Arbitrary, which means binary. Yeah, that's a good question. But
okay, let me think.
don't get too fixated on this. You can split it into chunks of any size. That's no big deal. You can break it into 1 megabyte chunks, 10 megabyte chunks. Doesn't make a difference. Or you can just tell me you break it into 100 chunks, which so that each one takes 0.1 seconds to copy.
Yeah, I think we could probably speed that up somewhat by just allowing the machines to even what we were saying in terms of, okay, once the copy is complete on one machine, the other machine can start copying it, right? We could just say once there's one, however, whatever size, we could start it sooner and have them. I think there's a potential to speed it up that way by having the machines be able to start as soon as there's any of the file content.
All right, let's explore this. So you got some small chunks of this file. Let's say you split the file into 100 chunks to keep it simple.
Or we could initially, I'm trying to think, would we want to go ahead and do that all from the local, when we do the local to the, to the first machine? Should we split it up at that point and give every little portion its own whatever ID or at least be able to know, so we could kind of cobble things together on the other machines out of order if necessary. Does that make sense?
That's an excellent idea. Let's combine it with the first one. So unrelated to what we just discussed, once we arrive at the idea that we can break the file into chunks, it's a genius idea that we can do it at source or your local machine. And then I think what you're saying is that I can have multiple chunks and I can send these chunks to different machines in a data center. That's an excellent idea. Okay, what happens next?
All right.
I'm asking, I mean, in a way, you already have solved the problem. So congratulations.
Yeah, basically,
but then
I think there would be the same kind of flow, right? So we would have chunks that would be sent to first available, and then there would be some kind of pub sub that would indicate that there's those different chunks that need to be copied, and that could fan out. And basically, instead of having, as we were saying, pools machines that have the copies ready, it would break out into pools with this chunk, pools with that chunk, pools with this chunk, pools with that chunk, and those would do the same thing, unless there's another way to do it that we can.
When you mention PubSub, ultimately the way PubSub would work in this case is approximately as you described with this fan out to multiple machines. So PubSub as an idea is a good one. PubSub, it's a good abstraction. It's a good way to think about it, but it doesn't answer the question. It's just see my previous idea. That's like the recursive trick. We still need the base case.
So there's something we want to do differently than just what we discussed before in terms of when we send the chunks, we're not gonna. It's not okay. Let's improve on it. So the split up file, the chunks are sent to multiple machines, and we're trying to define how the machines are going to sync up together in a way that's different than the pub/sub fan out factor thing that we talked about.
What I'm worried about right now is what is called orchestration. So if it's one file and you're doing this exponential full extension, so 1 to 2 to 4 to 8, etc., that's quite easy to explain how it works. You can just write a plan of what goes to where, when, and execute it. If you do it for 100 chunks or something like that, this whole orchestration thing becomes tricky. If you just think about how many operations would be needed, it's a delicate work to decide when is what copied where.
Right. So I think there would have to be like a key. Okay. I'm just thinking, okay, so if the file is split up in like 100 chunks, we would basically need like, this is just obviously it would be a different ID, but like keys from 0 to 100,
to 99.
Yeah, or yes. And the file, maybe even keeping, let's see here. So we want to know when each machine has the full file. And I think that there would have to be some kind of like manager that would track that. Let me think here how I would do this. So if it's chunked up and it's sent to a random number of machines, and we want it to keep the chunks to keep being copied. So I guess that's why I'm still like caught on the pub sub thing, because I'm thinking there's got to be something that's keeping track of the stat, like which chunks it has and which chunks it doesn't. And
I'm with you. That's
okay.
Exactly how it should be.
And
so when you say there's some knowledge of which chunks are where, this would immediately, I don't think we have a lot of time to cover this, but at this point we would immediately get to the question of high availability. What if the machine that has this knowledge dies, or what if somehow it's in a rack with poor network connection?
Right.
Ideally, your design would have nothing to do with would not depend on this single point of failure.
Yeah, I guess at this point I'm thinking like, okay, if maybe we have all the chunks sent to random amount of computer. Part of me wants to say like, chunk it out, send it to one machine, and then have that from that machine, all the other chunks, at least like have all of the chunks in one machine. Or, well, I want to
what if I tell you that chances are you have done something like this before? What if I tell you chances are you've used some software before that is doing exactly this? You just didn't quite think it does it.
I mean, this does make me like think about even one problem. I guess we discussed in a previous interviewing event. I saw like even just like capturing, like for example, like this whimsical right now is capturing what I have in the content of this window. And are they updating all of this every time, or whenever they get an update? Like sometimes you just want to save the one line. So I guess I'm thinking about abstractly of the file in the same way. It's like the file we're chunking out, and I'm not sure I'm getting to what you want me to get to, and I want to make sure that I'm like digging in as much as I can here. But so when we think about orchestration and the advantage of chunking out, based on availability and all of that, like having each machine kind of roll in and collect its chunks and have some way of knowing when it's complete. The concern you raised about being able to have the full file on multiple machines in case of a failure, are you thinking about like we should like, is that a reason not to chunk, or are you just pointing out that as reason
chunking is great. Chunking is great. Chunking is wonderful.
Okay.
Let me ask you one more thing before we get to Q&A and recap. You keep thinking that the way to distribute chunks from machine A to machine B can only be you had this assumption, I think, that the initiator of this transfer is always A. It's an A tells B, hey, I got this chunk. You got to have it too. Here it is. But what if instead of pushing, we consider pulling too? So B can ask A or someone else, hey, I don't have this chunk. Maybe you got it for me.
Okay. Yeah, that's good. Yeah. And that kind of comes back to, like, I guess most of the time when I'm thinking about like syncing things up and that thought about persistent data storage, that's kind of like, I'm thinking, okay, so there's one machine that has it. And instead of just like, oh, hey, A, B needs it, rather than start the orchestration from the perspective of like, okay, this event, so now all of you need these chunks. Here's the list of, like keeping track of the list of chunks with the file upload. And then at that point, all of the other machines are looking for other machines with that chunk. So similar, I guess that's what, so, all right. So let's just think about this for a second. All right, so the chunks made. Let's just assume that there's some key made where, we know which chunks are which. Copied to, one, machine from local, and then starts, I guess, like, this is my thing, again, I'm talking pretty abstractly here, but I'm thinking that at that point, each machine is like, there should be like workers that basically like, each machine knows which chunks it has / still needs. And each machine also should know which machines now have those chunks, and so that they can, read as quickly as, and copy that as quickly as possible. So whatever's controlling the orchestration should basically know everything. Okay, this, like, keep track, basically keep track of which machines have what. And as that goes, we can apply that same kind of exponential thing we had before with the full file.
Yep, I think it's going to work at the end. Exponential pool. Let's be mindful of time. I think it's time for Kevin. To jump in.
Sounds good. I appreciate everyone hanging in there with me, and thank you, Dima.
All right, so we want to have Dima explain, and we want to have Grace talk about what they just did, but a brief experiment just to make me happy. Grace, briefly, how did that go for you in like a couple sentences?
Yeah, I think initially I was a little nervous because there's more people watching than I anticipated. But I also, I think, relaxed into a conversation with Dima, and really, I think he was able to kind of like point me into vocabulary and like concepts I was more with. Yeah, I was a little nervous to start with, but I think we ended up having a good conversation.
100%. Dima, how did Grace do?
I would say so I was trying to be very gentle with hints, and we only had 30 minutes or 25 minutes.
And it's a coaching session. It's not a mock. It's a coaching session. So
I would say for the time we had, I had to give you slightly more hints than I would to a level 5 candidate, and slightly fewer hints than for a level 4 candidate. Mm-hmm. So that's, I would say it's actually pretty good, in a sense that that's certainly above level 4, and probably there's work to be done for level 5.
And if you had another hour, Dima, she'd be at level 5, because that's the magic of what you do. Dima's name is a verb. Dima's engineers. And so I think it's time for us to start talking about either, like, Dima, do you want to maybe do a brief analysis of what you're saying, of like what what an L5 good answer would look like? Before we get into the Q&A, do you want to tell people basically like what just a little bit more about this problem, or how people could approach it to do really well?
Yeah, let me take maybe 3-4 minutes so that I could both give some feedback and walk through. So I'm actually, it's partly my fault. I didn't time it well because I'm used to 45-50 minutes sessions. I think within 45-50 minutes at this pace, we would have gotten to the exact solution. The only parts left would be, hey, so you actually have it on the screen. You need the machines to know which other machines have which chunks. And this knowledge can also propagate between machines without orchestration. So when machine A is looking for a certain chunk, it can ask machine B. Machine B could say, hey, I don't have it, but I think machine C has it. Or maybe ask machine D, they have a better up-to-date directory. At which point we pretty much had a solution without orchestration. And the name under which most of you know the solution is called the Torrent Protocol. That's how torrents work. You break the file into chunks, and then there's this concept of seeders. I think even non-engineers know the word seeder. Seeder is the verb made of the noun seed. The seeder is a computer that is willing to send out, expose that particular chunk it has. And then to download the whole file, the only thing you need to know is the hash sums of each individual chunk of this file, at which point you just keep looking for seeders for each chunk. You download data from them, and then you become a seeder yourself. When people say P2P, peer-to-peer protocol, that's pretty much what they mean. So in my experience, it's perfectly doable to invent this protocol pretty much from scratch within 45 minutes, which I think is what you were on track to do had we had 45 minutes. Yeah, I don't think there's much to add here. Nice.
Okay, cool. So we could go to the Q&A now.
Oh, there's one thing I should add.
Yeah.
I saw some comments in the chat. Folks, you should be aware that I was asked this question at FAANG many years ago. This is a warm-up interview question on an SD session, for real. So I don't ask it these days often because it's kind of popular, but I figured Grace doesn't know it. So it was a good episode overall. But it's by no means a fake question. It's a real interview question for sysdesign, and this conversation does fit the sysdesign interview standards. And I can extract the signal. Yeah,
you could extract signal for any level. You could ask this question to any level, and you would expect their approaches to be different. But you could ask this to any level when you were at FAANG.
True. Yeah.
Yeah. Cool. Great. Okay. So getting into more of the Q&A, I'm really happy because one of the Q&A questions, the most upvoted one, is something that we answer in the guide. So the question is, how would you recommend, without any real experience working with large-scale systems, to approach system design interviews? And my friends, the good news is it's very simple. That's my desktop. It's very ugly. This is a picture of the design. It's not finalized. Professional experience with distributed systems isn't needed to pass system design interviews. And even if you do have that experience, keep in mind, many talented distributed systems engineers still struggle with the system design interview format. How you perform an interview is not a measure of your worth as a software engineer. The two are related but not equal. Being a good programmer has a surprisingly small role in passing interviews. That's the interesting part, but this is the nugget right here. So we asked somebody who used to work at FAANG this exact question that was asked in the chat, that was upvoted by all of you more than any other question. And we've heard it for the last several months. It's a very common myth. There is nobody at Facebook working on distributed systems except for a concentrated group of a handful of teams. So even if you end up working at Facebook, like this interviewer here, you won't learn much about distributed systems. This interviewer here says he learned more from reading the internal interviewing wiki at Facebook than he ever learned from working at Facebook when it came to system design. So nobody has experience with distributed systems except that 1% of distributed systems engineers. So you do not need distributed systems experience to excel in these interviews. So this is just like coding. Most of the algorithms you'd have in an interview, you wouldn't use on the job. So it's the same thing. It's just a intelligence test that they've determined is important, but it's not practical. So Moving on. Okay. Next question. This one's probably for Dima. We have one that is in the Q&A. How deep should I go into any one aspect of system design? I always wonder if I'm talking about messaging queues. I always wonder if I'm talking about messaging queues, if I should actually talk about a specific technology or how deep I should actually go into talking about load balancers. I have an opinion on this. Dima, tell me if I'm wrong. Do not mention a name brand of a technology, period, unless you know it very well and you know it well enough to have some idea of what a alternative technology would be. Basically, do not mention Redis unless you can answer the follow-up question of, oh, interesting, Redis. Why would you use that and not memcached? Dima, do you generally agree with that?
Yes, I would add that some technology names are synonymous with certain ideas. So when people say Kafka, it's not just Kafka as a product, it's Kafka as a collection of ideas that are encompassed in this product. But yeah, absolutely, by all means, be ready to answer what exactly does this product do, and why do you choose this one over the other one? Memcached versus Redis is a famous or infamous example. Yes, absolutely. Unless you can answer this question, better not say either of these words.
Yeah, don't say the brand name. The lesson is don't say the brand name unless you know it really well. Just say the type of the component. Okay, next question. Dima, this is a softball for you. I hope you hear what I hear when I hear this question. When you have a confusing requirement and you don't have enough specific knowledge in a particular domain area, what is your recommendation on moving forward and unstucking yourself? Dima, I'm not making that up. They use the word unstuck. What would you tell these people to do to unstuck themselves?
Excellent question. So there are techniques, tips and tricks, or as you like to say, Kevin, exactly what to say, degree of mentoring. What I would recommend is, imagine you're working with this person already. Imagine it's not the interview, you're hired. You need to solve this problem together. You're working with your interviewer as part of the same team. You need to figure out what to do. Chances are, folks, it's a lot of you keep thinking that the interviewer knows everything. Oftentimes, you would know more than they do in certain areas. So it's maybe it's a junior-ish interviewer who doesn't really know how to do interviews. They just read this wiki page and they only know that. So they would appear super knowledgeable, but it's not the case. So just keep asking questions gently and carefully. Keep in mind they might not have all the answers, but you need to figure out. You need to play this guessing game of extracting some hints without this person thinking that they're giving you hints. That's a skill, but it can be learned. Ultimately, if you don't fixate yourself on this idea that, hey, I'm going to keep using buzzwords, hopefully one of them resonates, like saying the words load balancers, pub sub, stuff like that. If you just honestly, sincerely try to solve it from first principles, chances are you will end up asking the question that would make you appear senior enough and let your interviewer help you get unstuck without deducting points from your ultimate score.
And the easy answer, part 4 of the guide is called Learn How to Get Unstuck. Okay, so you can't make this up. That's what it's called. And that's Einstein. Okay, next question. This one is kind of interesting. I think this is more of a clarification question about just like your decision-making process. Andre asked, why do we need this file to be present on every machine from the data center?
That's an L5 plus clarification question. So yeah, in practice, this interview question is kind of fake. It doesn't exist in this pure shape and form starting circa, I don't know, 2006, 2007. The short answer is that's the problem statement for the interview. If you can ask this question, you probably can solve this question right away. You probably know what torrents are and how they work. But trust me, good interviewers have tons of follow-ups. And I would immediately ask you, well, excellent point. What would you suggest instead? And we would have an interesting conversation, which can go level 5, 6, 7, depending on what I'm looking for.
So one of the most common things that I was getting chatted about during the meeting was people wanting to know, like, what are the differences between an how does an L6 answer look different? And people are asking that in the chat too. Like, what's the expectation for this question for L6? How would you say that what would you expect differently from an L6 candidate for this question?
I have to confess, I don't really believe in this competency matrices or whatever lists that compare levels. I just have some gut feelings. So I can try to answer this on a specific problem like this one, but I don't think I have a generalizable model. Overall, the biggest difference between I would say the biggest differentiator is 5 and below, so senior and below versus staff and above. And the biggest difference is senior and below tend to solve the problem. They try to collect requirements, maybe clarify certain things under the assumption that the requirements exist. They're cut in stone somewhere. And then once you have the requirements, you solve the problem. On level 6 staff and above, you try to make sense of the problem. You try to see how it fits the bigger picture. So not only you look for a solution given the constraints, assuming they are fixed. You try to tweak the constraints. You try to reason what would other teams do with your solution? What would it evolve into in the future? What other requirements may you need to worry about today because they will become critical in the next couple of years or so? You try to think about the team size. You try to think about, hey, this is an infrastructure work. It has to be super, super reliable because that's what the whole data center depends on, versus we can hack it and move on somehow. If you can demonstrate this level of thinking, and trust me, you can fake it. Honestly, up to level 5 or so, you can fake stuff by knowing the right buzzwords, the right keywords in the right places. Above the senior level, you really need to have experience doing that. So once you're there, you'll know it. Before you're there, it's really, really hard to teach you these heuristics.
Nice. I'm trying to look at any of the other ones that have been upvoted. Maybe one more. Oh yeah, somebody asked, what topic should you know to do well on these questions? And that one is easy as well. You should know the 12 fundamental technical system design concepts. And you can take a picture or wait to the guide to be released, and then we'll walk you through all of them. Okay, thank you so much to the participants. I would reckon that it would be very hard for any of us to get up on stage and do what Grace and Dima did today. Super thankful for anybody that came today. Hopefully you learned more about system design. I know I did. And we were trying to do a lot more events like these in the future. We really want to know what the community wants to see. For example, someone was like, I want to see Dima talk about, how an L5 candidate could turn into an L6 candidate, or how an L6 candidate could be seen as an L7 candidate. That's an idea of a workshop now that I have in my head that maybe we can do. So if you had any good loose ideas from today, like throw them in the type form after the event to just try to spur on us to do that stuff. And if you came, thank you. And I'm going to give a round of applause to Grace and Dima because that was amazing. So yeah, last thing, if you didn't hate the event, then tell your friends. Bring people next time. Share your experience online. If you want to do mocks on interviewing.io, go to interviewing.io and sign up. Do some mocks. And that's all.